So when we're writing things in rectangular mode, we typically try to solve them for y, so we can graph them, like y equals something x, so I can input it into my calculator. When we do something in polar mode, if your calculator was in polar mode, it would say r equals. And so when we want to go to polar mode, we want our equations to be in terms of r and theta. So the first three examples, we're going to go forward. Like if I have these in rectangular mode, what do they look like in polar mode? And then my second two examples, I'm going to go backwards. Okay, so if I have x equals 3, here's how these equations or conversions work. We're going to swap things out. So I'm going to take out the x, and I'm going to replace it with an r cosine theta. So this x is going to come out, and I'm going to write r cosine theta equals 3. So then I need to solve for r. What would I do? Don't even need to do that. It's like r times cosine theta. So I can actually divide by the cosine of theta. If I wanted a better way to write that as a trig function, dividing by cosine theta is the same as secant of theta. So this is the best way to write the equation. When we're putting this in our calculator, we're going to use the division by cosine of theta. Okay, so before I even do that though, we are more used to seeing things in rectangular mode. I mean, we can identify usually what the graph looks like a little better. X equals 3 is what kind of line? Not oblique. Oblique would be on x equals 3. Vertical line. So it's a vertical line at 3. I know, I almost said my snotty comment, but I didn't. It's okay. All lines are straight. Well, straight just means no curve to it. That's the definition of a line. Yeah, that's not a line. Line means straight. There's no such thing as a curved line. So, all right. So now, actually, though, we can't graph these in function mode because it's an x equals, and we can only put y equals in. However, in polar mode, we can. So let's get our calculators out a second and set it up for polar mode. So polar is, we've done function, parametric, polar. Let's also set it up for radian mode.
How do you know which mode?
When we're graphing polar things, we're gonna just be in radian mode. Most of the time we're gonna be in radian mode. I know it's hard to remember. All right, let's go to window. You can set up your theta. Why is it 6.2318? What did I put in there? 2 pi. And then let's do our x-min and x-max. Let's set it up like we normally would. Negative 10 to 10 for the standard viewing window, and negative 10 to 10. Oh no, I didn't type my equation in, and I left it from Friday. So what should I type in then? 3 divided by cosine of theta, and lo and behold, a vertical line at 3 shows up. Okay, yeah. We don't need to. We're talking about how to do it. Tomorrow we're going to talk about things, well, there's a couple things. You could graph things in polar mode that you can't graph in radian mode, but tomorrow we're going to talk about some specific, like, polar graphs that aren't anything significant when they're in rectangular mode, but they're kind of cool when they're in polar mode. Okay? All right, focus please. You're being recorded.
Oh, I still got the little snake thing down there?
Yep. If you want to hear that later. All right, so what do you think we're going to do for this one? So remember, I want to get an R theta. So we're looking at example 2. What do you think for that?
Well, we could go for the R cosine theta.
Oh, I could do X and Y, couldn't I?
For R sine theta.
Let's do it. So we're going to take out the X, and we're going to replace it with R cosine theta. And we're going to take out the Y and replace it with R sine theta. So I just used my conversions from above and took out X and Y. Alright, so now we want to get R alone, but I have two things with R in them. Can I factor the common factor of R out? Because this is all multiplication. Don't they have a common factor of R? Alright, let's pull it out to the front. If I did that, I would be left with 3 times cosine of theta plus 4 times sine of theta equals -2. Alright, so now I'm going to divide by this whole expression, cosine of theta plus 4 sine of theta. Okay. So before we graph this in polar mode, what kind of line is this? Now everybody's scared to answer now.
It
It
is a straight
is a straight line. Can you be more specific? It's oblique. Horizontals, so verticals are x equals, what are horizontals? Just y equals, and then when it has an x and a y, we call it oblique, but they're on some kind of an angle, some kind of a slope. Okay? So, I'm going to write here, just so we know, this is my formula. R equals -2 over 3 cos theta plus 4 sine theta. And it's an oblique line. Alright, so can you get it to show up? Make sure you use parentheses. Good question. Remember, theta is going around, and so it's telling us basically that if we don't make theta big enough or small enough, because we started our theta at 0, it's kind of similar to t, that we're not going to get the whole thing to show up because we restricted theta. If I made this -2 pi, I bet that part would show up. Maybe not. Nope. So it looks like I have to make it, would have had to make it go past 2 pi to get the rest of it. Alright, let's take a look at the last example. So just in general, it's helpful to know what these shapes are before you're graphing them. Does anybody remember what this is going to look like? It's from geometry. This is a circle. This is another thing that is a lot more difficult to graph in function mode. And the circle has a center of HK and radius of R. Okay, so on this one, what I'm going to do is I'm going to try to use the conversion x squared plus y squared. Above, what does it say x squared plus y squared equals? Yeah, so in order to do that, I need to expand this. Would you do that for me, please? Would you multiply out x minus 3 times x minus 3? Alright, so when I multiply this out, simplify to get x squared minus 6x plus 9. If I were to subtract 9 from both sides, what would happen here? Yeah. So now I have x squared. I'm going to rearrange some things here. I'm going to write x squared plus y squared minus 6x equals 0. Okay, so I'm going to break this into two different conversions. First of all, what can I replace x squared plus y squared with? Good. R squared. And then what can I take or replace the x with? R cosine theta. Okay. Now this is a little tricky because I have r squared and r again. So what I'm going to do is I'm going to actually move this to the other side and divide the r out so I can get r squared to be just an r. So if I moved this term to the other side or added it, I would have r squared equals 6 times r cosine theta, because if I added it to both sides it becomes positive. And then I'm going to divide both sides by r. Here's why I'm doing this, because you might think, well, why isn't she taking the square root? Right? When you input things in your calculator, it won't let you put r in, and if I took the square root, I'd still have the square root of r on that side. So I'm going to decide to divide by r. R squared divided by r is still r, but then it cancels it here. Okay, now I already told you, and I know most of you didn't remember, that this was a circle, and it actually has a center of 3, because h is 3, 0, and if r squared is 9, what's the radius? 3. So let's take a look and see if that matches when I put it in my calculator. Okay, I know it doesn't look circular, but that's because we have what shape for our screen? It's a rectangle.